Okay, so continuing the proofs, we're going to look at number 2. Go ahead and draw your T-chart. Label it statement and reason. So the very first thing that we always do is we write down our given. Our given is AM bisects angle GMJ, and GM is congruent to MJ. And we know that because it's given. Now, the next thing that we always do is we look at the given and we label the picture. So AM bisects, what is this right here? Is it an angle or a side? An angle. So if we're splitting an angle in half, we're going to have two congruent what? Angles. Okay? So GMJ is talking about this angle right here. It's telling me that AM is splitting it. So right here is AM. So that means that this angle right here and this angle right here is congruent. Now, does it tell me up there that these two angles are congruent? No. So we need to write that. So we can label this angle either as AMG or GMA. I'm going to use GMA, and I know that that is congruent. See how I started at G, which was way out on the corner? Then on this one, I want to start out with the letter way out on the corner, so this would be JMA. Okay, and so what is the definition for this one? Definition of bisect. Okay, the next thing that we want to label is GM is congruent to MJ. So GM is right here. MJ is right here. Now, do I have to write down that fact? No, because it's just given to us. Okay? Now, do I have enough to prove these two are congruent yet? No, I just have an angle and a side, so I need something else. So let's look at the picture. So what do you see in the picture that we could write? AM is congruent to MA. Okay, and that is reflexive property. Okay, now do we have enough to prove these are congruent? Yes. So, how would we prove that they're congruent? What theorem would this be? Oh, I forgot to label my picture. So it would be side, angle, side, and we have the same side, angle, side here. So I'm going to put SAS here. Now, I'm going to go up here and do the same thing we did earlier. So G, what side is corresponding to G in this triangle? J. Very good. And then they both share A, right? And they both share M. So I just have to make sure I put it in order if I can do yellow, blue, pink, or I can do yellow, pink, blue. Okay, so we'll do yellow, blue, pink. So G, M, A is congruent to, and then go in that same order, J, M, A. Okay, and so have we written our proof yet? No. So that's our very last step is our proof. So GA is congruent to AJ. So if I prove that these triangles are congruent, which means they're the same, doesn't that mean that every corresponding part would be equal? Yes. So GA would be the same as JA by CPCTC, or corresponding parts of congruent triangles are congruent. That is always going to be the last one. So you basically prove that the triangles are congruent, and then that's your last step. It's the same. The reason never changes. In this first one, there was 5. In this one, there's 4 before the last step. So sometimes, depending on what you're given at the beginning, It could be a 6-step proof, or it could be a 5-step proof. Okay? So we're going to do one more, and then we'll be done. Okay, so for number 3, we're looking at, go ahead and draw your T-chart.
So are these going to be like 6 to 5 steps?
6 to 5 steps, yes. Okay, so we're going to do statement and reason. The first thing we always do is the given, so Rn is parallel to MA, and RA bisects MN. And I know that because it's given. Okay. Now, the first thing we're given is Rn is parallel to MA. Do y'all remember how to show that? Yeah, show the arrow. So Rn is this line right here. We want to put an arrow to let me know this is parallel to MA, so I'm going to put an arrow on MA as well. Now, just because they are parallel, does that mean they're congruent? What does parallel mean? They never intersect. It does not tell me they're equal, it just says they won't intersect. Okay? Let's label the second thing. So RA bisects MN. RA is right here. It is cutting MN into 2 equal pieces. So that means MX is equal to XN. Now, does it say that up there? No. So I have to write that. MX is congruent to XN. And what would the reason be behind that? Definition of exactly what it says up here? Bisect. Okay, so we've done everything we've been given. Do we have enough to prove? No. So I've got to look at what's implied by the pictures. Okay, that's one thing. We have vertical angles right here. So let's go ahead and write down vertical angles. So how would I label this angle here? RXN is congruent to, we do AXM. Okay. Now do we have enough to prove? No, we just have a side and an angle, side and an angle. So we talked about it yesterday. Anytime you have a parallel lines, what's something you can look for to help you? Alternate interior. So which one of these do you want to be the transversals? RA. So we're going to let RA be the transversal. Could you let MN be the transversal? Yes, you could do it either way. So if this is the transversal, that means angle R and angle A are what? Congruent, they're alternate interior. So we're going to write alternate interior angles theorem. And it would be angle R is congruent to angle A. Okay, so now are my triangles congruent? By what theorem are they congruent? Angle, angle, side. Angle, angle, side. Remember, we're going the shortest path every time, so we can either say side, angle, angle, or angle, angle, side. We cannot say angle, skip a whole side and an angle, side, angle. Okay? Now, let's see. Do you think we can write the triangle without labeling it? Without doing the colors, do you think you can write it in order? Yeah. Okay. So I'm going to start with R, go to X, go to N. So triangle RXN is congruent to, what angle is congruent to R? A, so that means I have to start with A. Then I would go to X to M. Okay? So did we do our proof yet? No, that's the only thing we're missing. So we've got to do our proof. And that is RX is congruent to XN. So if these triangles are congruent, which we already proved, doesn't that mean their corresponding parts are congruent? Yes. So is x, our x, corresponding to... This is supposed to be XA. Because wouldn't that be the corresponding part? Rx is corresponding to XA. Sorry for that mistake. And that would be, what's the theorem for that? CPCTC. Very good.